Hi, I'm Naranjan. I'm going to present my project StockSense. I'm a data science graduate student at the University of Colorado Boulder, and this project is part of the course Machine Learning under instructor Dr. Gates, and this is focused on the domain retail supply chain management. The agenda of the presentation is I'll start by explaining a major challenge faced in the supply chain management and the objective of the project, followed by I'll give an overview of the data set used, and then I'll walk you through my solution and finally discuss the result and outcome. While shopping online or in a retail store, have you ever faced this frustration of your favorite product that you've been waiting to purchase for a very long time, running out of stock? Now, this is not just a letdown for customers, but it's a major loss for retailers as well. Retailers usually purchase product from the manufacturer, store it in their inventory, and then sell it to customer as per demand. Now, this problem starts during the purchase period. A recent survey revealed that all the retail stores in the United States lose around $300 million just because of poor inventory management, and half of them responded that this happened because they weren't aware of when to purchase which product at what quantity. Now, the consequences of these are far-fetching, starting with dissatisfied customers, which results in a decrease in brand or store's perception, followed by decrease in sales and profit, unnecessary inventory holding costs, write-off inventory, and more. So, the objective of this project is to determine the ideal purchase timing and quantities to prevent overstocking and understocking in a retail store. For this project, I've used the Bibitter LLC dataset. Bibitter is a wine and liquor company, has stores all across a fictional state called Lincoln. Now, this dataset is a complete one covering the entire supply chain life cycle. It has product movements in the year 2016 across 80 different stores and covers over 10K products. This is how the raw tables look like. They are a bunch of unclean, unorganized, messy data that also contain a lot of redundant information. So I extracted information from them and organized it and created a bunch of analytical tables that reduced the dataset size by 75%. Now each one of these tables have uh, focus on different aspects of inventory management. For instance, this table focuses on all the purchase and order information along with the fulfillment details, and this table focuses on all the sales information, and these two focused on the products information along with its selling price and purchasing price. This problem was solved by considering three main factors: the current inventory level of a product, and the expected demand of it in the upcoming weeks, and finally the fulfillment time required by the manufacturer after the retailer places an order. Now, inventory level and fulfillment time can be extracted from the analytical table by joining one or two analytical tables. However, product demand is something that needs to be forecasted. So the solution started with sampling the dataset, followed by demand forecasting, and finally calculating all the purchase metrics. Sampling. Out of 80 stores that were present in the dataset, one store was selected as a sample for this analysis, and this was performed by looking at a few metrics like total sales and number of sold quantities. And the store that had all these quantities close to median was selected as a sample. And this selected store was selling around 2,000 products in a year, and each one of them had different profits and demand. Four products out of this was selected for an analysis, and that was performed by first clustering the products into four different groups using a hierarchical clustering method. And the four groups were cash cow, that covered all the products with a very high demand, which was sold almost every day, but it was sold for very less profit. Laggards were the products that had medium demand and also was selling for very less profit. And finally, commodity and luxury are the products that are sold for very high profit, but they were rarely purchased by any customers. Now, one product from each of these clusters were selected as a sample for this analysis. Overall, one store and four products were chosen. Demand forecasting. The demand of those selected products were forecasted on a weekly basis using a neural network model called long short-term memory. Now, this model was trained to predict the demand of current week based on previous 3 weeks sales. And it was trained using the first 43 weeks of data, and it was tested on the last 10 weeks. Now, this is the prediction result of the cash cow product. Look at the predictions in the last 10 weeks, and the same was created for all four products. Notice that especially in low demand products like commodity and luxury, the predictions were not super accurate. The model were not able to capture all the trends because of their volatile and unpredictable sales in the past. However, this is very trivial because all we want is our model to understand the overall trend and give us a prediction, but not to just uh, make a prediction that is super accurate. Because this by itself can be used to cut down a lot of cost and inventory space that we'll be discussing almost by the end of the presentation when we talk about the result and outcome. Now that we know all the product demand, the other two metrics were also calculated. Fulfillment time is basically the fulfillment time. It's basically the number of days taken by the manufacturer to deliver the product after the retailer places a purchase. So now, on an average, the fulfillment time was around 7 days, a little over 7 days for all the products, and that was considered while placing a purchase as well. So, for example, when planning for week 45, the solution was made sure to place a purchase by the week 43, at least by the end of week 43, in order to meet all the requirements. And finally, the inventory level was also calculated using a very simple formula. This basically the stock availability of current week. The starting of current week is basically the stock availability of the starting of previous week minus all the products that were sold in the previous week plus all the new products that were delivered in the previous week. So that's how stock availability was also calculated. And yeah, and now that we have all these three factors that are required for the calculation, the purchase metrics were calculated. Now, the purchase quantity of every week was calculated using this formula. Let me demonstrate it using a dataset. Say I have this dataset from the Lagarde product of 45th and 46th week, and assume we are at the starting of the 45th week and we want to predict the purchase quantity for that particular week. So we will first apply this formula, and where we first we first subtract the stock of the current week minus the demand forecast of that current week, which will give us the estimated stock availability by the end of that week. That is subtracted from the demand forecast of next week, which will give us this number 3, which is basically the number of quantity that we still need in order to meet that demand. Now that is the purchase quantity we require for that particular week. Now let me explain why do we have this max function as well. Take the 52nd and 53rd week data of the same Lagarde product, where when we first subtract 12 minus 4, we'll get 8, which is the stock availability expectation, and that when subtracted by 2 will give us minus 6, which means that we will be having additional stock even after the sales of the next week. So that is basically mean we don't have to make any purchase in the current week. So that's what represented that is calculated by using this max function. Now this is calculated the starting of every week after updating the demand forecast and stock value from the previous week's actual in order to optimize all the purchase quantity. In order to measure the impact and outcome of this project, the potential monetary value saving and inventory space saving was calculated by comparing the overstocked and understocked quantity of actual versus the ones that we would have got by following the prediction. Now let me take the example of Lagarde to demonstrate this. Now these are few values that are needed to calculate these overstock and understock metric. Both of these were calculated for actual and the ones that would have received by following the prediction. Just by following our prediction, we could have saved 46 products from overstocking and might have ended up understocking 5 products. Now this one converted to a monetary value based on the purchase price and selling price, we could have saved an overall of $200 and also an inventory space for 5 more products. Now the same calculation was applied to all the products, and the commodity product was the one where we could have saved a lot because the retailer was overstocking this product already when there were no sales happening, and on top of that he made purchases in few weeks when it is not really required. So that and also on top of that, commodities products are sold for more profit, and they usually have a higher selling price. That resulted in a huge monetary value that could have been cut. Now Overall, we could have saved almost $8,000 and there's a space for 300 products. Now, this is just and value that was calculated for one store, that is our sample of one store, 10 weeks and 4 products. Now this is when projected to the entire data set could have resulted in a savings of over 1.9 billion. Now this projection is very vague, and this could be way off from the actual, but it highlights the importance of calculating the right purchase quantity and optimizing the inventory. So and also the impact of this project. So yeah, this is the end of the presentation. Feel free to reach out to me for any questions, or if you'd like to discuss more about this. Um, Thank you.